And I thought it was hilarious that all of the kids had rain boots and a raincoat on to play at the park. I'm like, just in Seattle, that's how you play at the park, right? You just put on your rain gear and you go.
Pretty much. I think Seattleites do not carry umbrellas around because it's just, you lose it all the time. You have to basically carry it all the time if you're in Seattle. So there's instead just rain gear.
Yeah.
All right. I think we're all set up. It looks like we're good on LinkedIn and YouTube. Hi, everyone. Thanks for joining us. Awesome. Looks like YouTube. Okay, we're all set. So I know that we have a super packed agenda, which I'm super excited about. We have four speakers here with us today. So I'm going to just share my screen quickly with a few housekeeping slides, and then we'll go ahead and get started. I can see my 100 tabs open. All right. Cool. So I am very excited to announce this is our first community lightning talk session. For the past couple of months, I've been reaching out to all of you and asking for you all to submit projects. We want to hear from the community and see all the cool things that you're working on. So we finally got a session together, and this is the first of hopefully a few more this year. And also kind of leading up to Summit next week. I can't believe it's next week. It's come up so quickly, but we have a ton of awesome content that I'll share with you in a minute or so. But I just wanted to quickly highlight our four speakers. So we have Franco, he's a senior solution architect here at Databricks. We have Shivani, Director of Engineering at Informatica. We have Alyssa, CEO and co-founder of YLogs. And then we have Liang, software engineer here at Databricks. So four awesome speakers here to give a quick lightning talk. So if you're joining us here from YouTube or LinkedIn, this event is part of the Data and AI online meetup group. So we run tech talks, AMAs, different sessions. This is our first community lightning talks sessions, but I'll drop that link in each of those chat spaces. So I hope you'll join us there. We have a lot of cool stuff coming up. I hope you'll check it out and keep tuning in. And then also you can always subscribe to our YouTube channel. We host or we have all of our recordings there on our YouTube channel. So all of our tech talks that we run, all of our meetups, and also all of our summit content is put up there. So lots of awesome content. And then LinkedIn, we host a lot of, we have a lot of different events and updates and so forth. So you can follow us on LinkedIn as well. Lots of spaces. So just again, a quick call out. This is part of community lightning talk sessions. So I wanted to put this link here because if any of you are interested in submitting a project idea, I'd love to hear from you. So really the idea, I'd love to run a community lightning talk session at least once a month would be great, maybe once a quarter. So submit your project. Really, a quick 10, 12-minute presentation with a few minutes for Q&A. And topics are really, broad, whatever you're working on that relates, we'd love to hear from you. So I'll drop that link as well, or you can reach out to me directly and I can give you more information. And I want to do a quick plug since Summit is coming up next week. We have over 200 awesome technical sessions. Also to our team, I'm part of the developer relations team, and we're running 4 meetups. So after each day of the conference, we have a really cool meetup scheduled with some technical talks, some demos. And then we also have 4 community lightning talk sessions. So I think it's something like 12 or 13 additional lightning talks that we're going to run over the course of a couple days next week. So tons of awesome content. So I encourage you to register. Registration is free. And I'll also drop that link once we get started with our speakers. So with that, I will pass it to Liang. Just a quick reminder to everyone, speakers have about 13 minutes or so for their presentation. And we do have a minute or so for each speaker to answer questions. So if you drop your question in the chat spaces, I'll do my best to capture those. And if there is time at the end of each presentation, the speaker will go ahead and answer a question or two if they have time. So with that, I'll pass it over to Liang.
Yeah, thanks, Karen, for the introduction. And let me share the screen. Can you see it?
Yep, looks good.
Okay, so hello everyone. Welcome to our community lightning talk session on simplified data conversion from Spark to TensorFlow and PyTorch. My name is Liang Zhang. I'm from the machine learning team at Databricks, and I've been working on making ML training on Databricks simpler. I've joined in Databricks for almost 2 years now, and prior to joining Databricks, I had a master's degree from Carnegie Mellon University. So first, let's talk about the agenda for today's talk. I want to start off by a motivation for why we should care about the data conversion from Spark to deep learning frameworks. Secondly, I want to highlight some pain points in the existing methods to do the conversion. Then I want to do a quick overview of the Spark Dataset Converter and how to use it. And at the end, I'll wrap up the talk with some of the best practices for using the converter. So let's start with the motivation for why we should care about the data conversion from Spark to deep learning frameworks. Suppose you have a large data set of images from your driving camera, and you want to detect the traffic lights in the images. The amount of data is as large as terabytes, and there are new images coming every day. Before feeding your data into machine learning models, you want to do some data cleaning and labeling. You think it's a good tool to address the first 3 issues. After you are satisfied with your data set, you want to use one of the most popular deep learning frameworks to train a model and periodically retrain the model with new data, and finally predict the labels of new images. So here we find the problem: how to combine the power of Spark with the deep learning frameworks to extract value out of your data. Is there a convenient tool in the position of the red dot that can seamlessly connect 2 parts and increase my productivity? Before providing the answer, I'd like to illustrate the pain points in the data conversion from Spark to deep learning frameworks. Let's go through the stages during the development of the traffic light detecting project. First, we'll always start from building a single node project using a sample of data, so that it's fast to test the correctness of your code and debug potential errors. In terms of data, we will probably collect the data into a pandas data frame or just directly load the image files. After we are confident about our single node code, we are ready to train the training the model with all the available data. We need to save the data from the Spark DataFrame into a TF record files if you are using TensorFlow, or into other formats if you can that you can parse in PyTorch. Now that we can identify 2 pain points in the proposed workflow. First, the data handling in the single node training code and distributed training code will be very different. To migrate your model from single node to distributed setting, you are essentially rewriting all the data. Second, in the distributed training scenario, you need to write many lines of code to save, load, and parse the intermediate files. And it's time-consuming and yet unrelated to any novelty of your machine learning model. It would be convenient if we have a tool to do the common boring operations for us and help us to focus on the unique part of a deep learning project. So now I have hopefully given you a bit of motivation for why we should care about the data conversion from Spark to deep learning frameworks and the pain points of simplifying the conversion. I want to talk about how you can get rid of these pain points by using the Spark Dataset Converter. In the high level, the Spark Dataset Converter takes the data from Spark and returns a TensorFlow dataset or PyTorch DataLoader for you. And here is a minimalist example to show that what the converter API looks like. You may notice that the Spark Dataset Converter is built on top of Petastorm and can be found in the petastorm.spark package. For those who haven't heard about Petastorm, Petastorm is an open source library to load Parquet files to deep learning frameworks. This graph gives you a closer look at what the converter does for you. The functionality of the converter is shown in red color in this graph. It takes the data from the Spark DataFrame, check whether the data is already cached, and that is persisted in the distributed file system, and persisted if not. Then the converter will load the persisted Parquet files into the dataset PyTorch DataLoader. Specifically, the Spark Dataset Converter has the following features. It will cache the intermediate files, and the way it recognizes the same data frame is by checking the analyzed query plan. It will also automatically delete the cache files at program exit. Second, it's easy to migrate your code from single node training to distributed training if you use the Spark Dataset Converter to load your data. You only need to change 2 arguments, and we'll show you in the demo notebook. Thirdly, for those who use the vector assembler to extract feature vectors using Spark MLlib, the Spark Dataset Converter will also help you to automatically convert the MLlib vector to one-dimensional arrays in the TensorFlow Dataset or DataLoader. Here are the links to the notebooks demonstrating an end-to-end example for using the Spark Dataset Converter to do image classification with transfer learning. For the sake of time, I cannot walk you through the code in this lightning, but feel free to take a look offline, or you can go to my breakout session in the Data AI Summit, where I will explain the example notebooks in details. To wrap up this talk, I would like to call out some of the best practices for using the Spark Dataset Converter. First, if you're working with image data, you should decode the image in the transform spec function instead of doing the decoding in Spark. That will increase the size of the persisted data, and it will also be slow. Besides spec, you may also choose to do some pre-processing in the dataset.map or in the model. You can look for the pros and cons of different methods in the discussion online. Second, as is shown in the demo, we encourage you to generate infinite batches of data using the default value of number of epochs, which is none by default, and we didn't specify it in the demo. That makes the control flow easy to understand and also guarantees that in the distributed training, every worker gets exactly the same amount of data. Lastly, we encourage you to configure the life cycle of the bucket that stores the cache data so that you don't need to worry about any data leakage. Yeah, thank you for attending the session, and I hope you find this talk helpful, and feel free to raise any questions. Thank you.
Thanks, Liang. We do have one question. There's a few folks on LinkedIn that are asking for you to share the link that you just mentioned. Maybe you can go.
Yeah, you can just search for the title of this talk, and you'll find a blog post and also documentation on the Databricks Databricks documentation webpage, and the example notebooks are there.
Okay, Great.
Yeah,
Then
I can
I
also
will.
share the links.
Yeah, that'd be great. If you can share the links in the chat on Zoom, I can copy those over to LinkedIn, and then I can update the description on YouTube.
Sure. Yep.
Awesome. Cool. I don't think I see any other questions. Just reloading LinkedIn just in case. Looks like we're good on YouTube. Okay, I think we're all set. So I'll pass those links along when Liang posts them in the chat. But next up, we have Alyssa. Take it away.
Hello. Good morning, good afternoon, good evening, all over the world. Thank you for joining today's Data and AI Meetup and the inaugural Community Lightning Talk session. Thanks for inviting me, Karen. My name is Alyssa Vishnik. I'm the CEO at YLabs, the AI observability company. And today I would like to present an open source project that fills a huge current gap, in my opinion, in the production machine learning stack. So thanks to Databricks and other big data platforms, machine learning engineers are able to build pipelines that can process terabytes of data in minutes. Just like Leanne gave an example in the previous session, there are many tools that are available to ML practitioners that allow them to work on massive, massive amounts of data. This is both a blessing and a curse. If you look at the 4 core steps in the machine learning stack: processing raw data, generating features, training the model, and serving the model, each one of these steps is transforming and moving terabytes of data. When you operate such a stack in production, you quickly learn that each step can introduce a data bug or can be completely derailed by a data bug. Machine learning models are very, very sensitive to data bugs and data changes. In fact, the majority of machine learning problems and failures come from events like missing data, duplicate data, from bad data quality, and data drifts. In fact, when operating a machine learning model in production, your most common daily task is probably answering questions about its behavior and health. Questions like, how is my model performing? Has my model drifted? Some of these questions are easier than others. However, each question typically involves figuring out what happened to the model in the past and why did it behave a certain way. And every engineer who answers these questions regularly has their own improvised way of answering them, of testing the data that was passed through the model, of monitoring data quality, and of debugging what happened to the model and the data. It's probably an ad hoc process. It likely involves pulling a lot of data from storage, reproducing the pipeline, writing complex ETL queries, processing the data, visualizing the data, and producing your favorite Jupyter notebook. This is incredibly tedious. So imagine if instead of running a tedious manual process every time your model fails or you get an undesirable model behavior, there was a way to continuously monitor the quality and the shape of the data flowing through each stage of the machine learning stack. Imagine if you could be alerted about data changes, about schema changes, data outages before they impact your model, and answering these questions would become completely streamlined. So after many years of answering such questions and supporting machine learning applications in production, my team and I at YLabs set out to build a data logging solution that makes answering these questions a breeze. So today I'd like to quickly introduce a library called YLogs. It's a purpose-built machine learning and data logging library, open sourced by our team at YLabs. YLogs is built to provide lightweight, portable, configurable, and mergeable data logs for both batch and streaming data workloads. Check out the bit.ly link to get to the GitHub page. So today already, YLogs is making the lives of AI practitioners all over the world much easier because they can streamline such activities as testing, monitoring, and debugging both data and machine learning models. The library is available in Python, Java, and Scala under Apache 2.0 license. So let's spend the rest of this talk looking into how does this library work, how does it integrate with common data tools, and how does it make your life easier? So your pipeline is constantly flowing and crunching a lot of data. In some cases, you don't even keep a record of what data was processed. The data is basically ephemeral. And when you're tasked with answering a certain question about data or model behavior, you have to essentially reproduce the entire data flow. This is expensive, tedious, and time-consuming. YLogs solves this problem by logging all key statistics of your data over intervals of time. So instead of reproducing the data and reproducing the entire pipeline, you just load a log file. Well, there are also many open source libraries that try to tackle the same problem from different angles. Libraries like DQ and Great Expectations help you implement data testing and data evaluation. YLogs takes a very different approach to this task. What it does is it implements a standard for representing a snapshot of data. And this allows the user to decouple the process of producing data logs or data statistics and acting upon them. So YLogs this way provides a foundation for activities like profiling, testing data quality, monitoring, and so on, all with just a simple log file as a foundation. Since we are at the Data and AI lightning talk session, I'd like to talk about how YLogs integrates into Spark. This particular example, we're taking a popular public data set about wine quality and profiling each feature with YLogs. All of this is done in just a few lines of code. And behind the scenes, YLogs uses stochastic streaming algorithms to sketch key statistics about each feature. YLogs seamlessly integrates with the Spark DataFrame API, which allows little to no configuration from the user to get started with YLogs on Spark. And the YLogs UDFs are implemented in Java, taking full advantage of Spark's raw processing power, which allows you to log terabytes of data. And it requires only one pass over the data to calculate all of the statistics that you need. So the performance of such computation is so efficient that you can run YLogs in parallel with your main data workloads, just like traditional logging. The resultant output, the log file, can be stored in Parquet for post-processing and analytics. So here's an example, a sample partial output of YLogs on that wine quality dataset. YLogs captures key statistics per feature, things like counts, distinct counts, summary statistics, histograms, and so on. The default configuration that requires no configuration specified by the user would infer the schema and calculate about 30 features, 30 metrics and statistics per feature. The log files then can be converted from Parquet to CSV and JSON for easy manipulation. And an example of a converted log file to CSV is here in this table. This data log contains all information you need to understand the quality, integrity, and distributions of the data in your pipeline. And the type of metrics YLogs captures is configurable and it's open source, so we would love the community to contribute new metrics and ideas. Now, if you're already using something like MLflow to version your pipeline and manage the life cycle of your models, you're already storing valuable artifacts associated with each run, such as model parameters, performance metrics, and so on. If you use YLogs with MLflow, as shown in this example, it would add a data log artifact for each job with just one line of code. And similar to other MLflow tracking APIs, YLog would profile and collect the data log file in just one line, making it extremely convenient. Using YLogs with MLflow will add something like a data transparency across the entire ML lifecycle. Anywhere you're processing data, you can persist a data log file with YLogs. And the resulted artifacts can be visualized in the MLflow UI and using YLogs built-in visualizations. Furthermore, the resulted artifacts, as I mentioned before, can be used to continuously monitor data quality and debug data by running things like quick exploratory analysis or enabling data unit testing after every run. This lightning session is a preview of the talk that I will be giving at the Data and AI Summit next week. In the talk that I'll be giving on May 26th, I'll be discussing key design principles of a data logging library and how to implement them. Then on May 27th, at the Data and AI Summit, my colleague Andy will be giving a talk about building an ML monitoring solution on top of YLogs and Spark. And finally, on May 27th, my other colleague, Leandro, will showcase how to enable logging for non-structured data, such as images, for example. Please join these talks to learn more about YLogs. So finally, check out the bit.ly link that is shared here. It's the link to the GitHub package. Try YLogs. Be amazed at how much easier it will make your day-to-day ML operations. Send your feedback, contribute, and help us build integrations into your favorite data tools and extend the concept of logging to new data types. In short, please join us to help build the open standard for data logging. Thank you. And my information, my email and Twitter are listed here on the slide as well. I'm a huge data nerd, so please engage. Let me know what you think about YLogs, and let's talk about MLOps and data processing.
Thanks, Alyssa. That was great. I was just finding your session on the Data and AI Summit website, and I posted that link in the chat spaces. So hope you'll check out our talk. That's really cool. You also have some colleagues that have some sessions coming up next week too. So awesome. So I'm checking LinkedIn. Everybody seems pretty quiet. I don't see any questions yet, so maybe we could just give it a second.
Maybe most people are just waking up.
Zoom. Yeah. we do get a lot of folks in the Bay Area that join us. Okay, well, if you'd like to ask, a question, if you think of something at a later date, Alyssa, you can reach out to her in LinkedIn or Twitter too. And then Zoom, the speakers will be hanging out, so you can always ask a question. Oh, we have a question from Tim. Does it work with PyCarrot? So Tim's on Zoom asking.
Hi, Tim. Thanks for asking. We do not have an in-depth and one-line integration with PyCarrot yet, but we do have the Python version of YLogs. So would love to connect and figure out how to build a one-liner integration to make it work easily.
Cool. All right. Well, with that, let's pass it to our next speaker. Shivani, you're up.
All right, thanks, Karen. Let me share my screen. Okay, please let me know that you can see it.
Yep, looks good.
Okay. Awesome. Great talk, Alyssa and Liang. Good morning, good afternoon, good evening, everyone. Just to give a little bit of introduction of me, I'm Shivangi. I'm Director of Engineering at Informatica. I have a decade of experience working in distributed computing, database systems. Right now, my main focus is Spark. If folks are not aware what Informatica is, we are one of the leading providers of data engineering solutions. We build products for data integration, cloud data management, data quality, and et cetera, et cetera. But for all of these, we utilize Spark heavily, and we enhance Spark to optimize it for our use cases. So as part of this talk, I will be walking through one of the optimizations that we've done, which is a very common optimization for data integration and ETL pipelines. So the agenda is very simple. I'll walk through some background. I'll walk through the proposed solution that I have. We'll walk through some performance numbers that we've seen with the optimization. So just to give a little bit of a background, the pipeline that you see here is one of the very common pipelines that you'll see in like an ETL use case. You read data from a certain source. It could be multiple sources. You kind of pre-process the data, cleanse the data. And then once you've done that, you most likely use a construct like router. And router is nothing that helps. It's just a construct that helps you then filter this data out into multiple pipelines. So it could be a scenario where you're doing change data capture. You pre-process the data, and then you say that, hey, this is my insert pipeline, this is my update, and this is my delete. Or you could be doing things like, hey, I'm processing COVID data, and I'm doing it for United States, but now I wanted to split it in between different states, so filter it based on California, Arizona, et cetera, et cetera. So you do end up splitting the pipeline very often. Now, why is this a problem? Well, with Spark, it does lazy evaluation. So every time you have an action, that's when the execution starts. So for a typical scenario like this, you will first execute the first action, your pipeline will trigger, you will execute the entire pipeline, then you would go to the next one, and then you're going to the next one. So as many pipelines as you have, you are executing the same pipeline again. There are some inbuilt optimizations, but you could end up running the whole pipeline depending upon how you're running these optimizations. Now, what you possibly want to do is not wait for every action to execute before you run the next action if they're not dependent on one another. So as a first step, what you want to do is basically optimize this pipeline so that they are running together if you have enough compute capacity. So what we did was basically we created this new executor, which we call as an async executor. This does utilize the concepts of thread pools and Scala futures. I'm not going to look at the code in the interest of time, but then basically you're creating a very simple implementation of thread pool. We intentionally didn't use thread pool because we wanted to have different guarantees for the async executor. Now here we are making certain assumptions. We are looking at ETL pipelines. These are bad jobs, long-running jobs where you're processing large amounts of data. So re-execution of pipeline is something that you don't want, and you assume that you have large clusters where you're able to process this data. So what we want to do is, as soon as a task is submitted, you want to kickstart it in the background, and then you're not doing any CPU load management here. You're just handing over the task to be executed, and you are aware of the ordering of tasks, so you know in which order these tasks need to be executed. So how does this help us? Basically, we're saying a task that was essentially taking if I had these three pipelines, the time of execution was basically sum of T1, T2, T3. I'm bringing it down to a max of T1, T2, T3, assuming I have enough cluster capacity to run all three of them in the background. So let's say we did that. And now I have this whole async execution going on where I'm not waiting for the actions to complete, but I'm starting all three of them in parallel. I still have a problem. Now, my pre-processing pipeline could be very, very expensive. And usually that's the case. I am processing terabytes of data here. I'm trying to cleanse this data, apply data quality operations. There could be expensive shuffle operations in my common pipeline. If I have to re-execute it, I am spending a lot of time processing this pipeline over and over again, depending upon how many filters I apply or how many branches I have after my common pipeline. So I want to be able to avoid that common processing of this pipeline. So a natural instinct would be, hey, let's go and process this data frame. So I will avoid the common pipeline to get executed again and again, which is a good optimization that should be our first step in figuring out how do I want to optimize it. But there's still a problem here. Now, what is our bottleneck here? I did avoid the execution of the common pipeline, but I'm still rescanning this data frame one again and again, because at this point, I'm saying that, hey, every subsequent pipeline needs to be able to read from this data frame one. And most likely, this data frame cannot fit into your memory, so it's getting persisted onto this. So you're like serializing, deserializing the data, being able to read it, re-executing it. That operation itself can still be expensive. So you want to optimize that as well. So what we did was we wanted to be able to process this data frame one only once, and we wanted that every subsequent pipeline is only reading the data that's relevant to it. So instead of persisting with this data frame right when we've executed the common pipeline, we moved the persistence option. And then we said that, hey, let's persist it post at the application of filter so that you're not the next subsequent pipeline, which is executing in parallel. It's looking at the data that's only relevant to that execution. How do you do that? So what we did was, instead of using Spark's persist framework, we defined our own custom persist logic. What is it doing? It is saving the file in a Parquet format, which helps with the downstream applications to basically just rely on Parquet pushdown. We created a new column in this Parquet file, which is basically the indicator of who is supposed to be consuming what data. What we are doing is we are creating like a bitwise operation to say that every bit represents the one output group of the previous pipeline that we looked at. So you know whether my filter was true or false. So the first time you read it, you created this new column with a condition to say that, hey, if the condition is true, then it's a 1, otherwise it's a 0. And now I'm staging this file and I'm partitioning it by the new column that I've created. So every subsequent pipeline that comes in is only reading the required partition, and it's not going through the entire scanning and reading the entire data frame that was available after doing the common processing. Why is this helpful? Well, we are saying that I'm just staging it in the Parquet format with an already partitioned file. Once it gets evaluated, I will utilize the filter pushdown for Parquet to read only the subset of data that I need to use. So if I have 3 filters here, a terabyte of data, you end up rescanning only a third of terabyte, which is relevant to you. You're not reading the entire data set. And you're also staging only what is required. So if I was producing, let's say, as an example, a terabyte of data after doing the common processing, I would have to stage everything. But in this case, it's possible that I have multiple filters. And the example that I showed was very simple, where I was just filtering and writing out the data. But it's possible that every subsequent pipeline also does some amount of processing. And some of these pipelines can be optimized out because they don't ultimately lead to something that's getting written, because there is a filter in the future that you can push forward and you can apply further predicate optimizations to say that this pipeline is not relevant. So we will be able to analyze the DAG to figure that out, push the filters forward, and eliminate anything that is not necessary. So you would not end up staging the entire file, but only the information that you need to be able to process the subsequent data. So that also reduces the amount of data that you're writing to disk. Now, after doing all of these optimizations, I'll walk through the performance numbers, but I do want to call out, of course, this is an optimization, so we need to use it when it's applicable. You want to be aware of scenarios. If your common pipeline is really small, if you have smaller data sets, it might make sense to re-execute the pipeline. This optimization is mostly relevant for use cases where you have large amount of data and your common pipeline is complicated enough that you know that you are going to be running into scenarios where it becomes effective. So this is the first performance result. I was working on the TPCH data set. This is scale factor 100. So we are looking at about 100 gigabytes of data. And this is like the simplest of use cases that you can have. It's not doing anything. It's just reading S3 from a CSV, a source, and then it has this router construct where basically I'm applying 3 filters and writing to an S3 target. And all it does is it's basically splitting it into 3, 5, or 7 filters. So that's as many pipelines as out there. And you can almost see like a linear growth in the amount of performance optimization that you see. If you have smaller number of filters or pipeline branching, your performance, you still see a significant performance benefit. You have about 16% performance benefit here. And but as the number of groups start increasing, which could be a common enough scenario for your ETL use cases, you see that the performance benefit like spikes up to a 48% here. Now, this was the simplest of use cases. We walked into it with the assumption that, hey, I am doing something really complicated in my common pipeline. So again, so just to kind of add a little bit more complexity, I said, okay, here I'm reading from source. I'm going to do an aggregation where there's some amount of shuffle that would happen. And then I would take that and I would split it into filters. And again, I have these 3, 5, and 7 groups that are going out of here. And with just that, you can see that the performance benefit bumps up because here your common pipeline was actually doing more work. And now that you've optimized around it, you can see even with 3 groups, you can see like a 23% performance benefit. And as you go up, you can see a little more than 50% performance benefit. And as these groups go up, we can see a linear improvement in our performance that we observe by applying this optimization. Okay, so that's all I had. I wanted to very quickly go into the performance optimization and walk through it. if anybody is interested, I can share some sample code to kind of walk through how our async executor looks or how the staging looks. But in short, that was it. Thank you. And if there are any questions, I can take them.
Thank you, Shivani. That was awesome. I am just checking LinkedIn. So someone did ask on LinkedIn, what is the purpose of pipeline and optimization? Does it precede the data and in which format? Now my cover on again.
Actually, is that question on the doc? Let me quickly read it.
Oh, sorry, no.
Or from the chat.
Sorry, I was reading directly from the chat on LinkedIn.
Okay,
sorry,
do you
I need to
mind
refresh
repeating that, Karen? Oh, I can.
Sure. Oh, sorry, it was on, yeah, here, let me paste it in. We have a doc going where I'm capturing all the questions for our speakers. So just bear with us one moment. Okay, I put it in the doc. It's what's the purpose of pipeline and optimization? Does it process the data and in which format?
So it can process data in any format. There's no restriction. The common pipeline is whatever you want to write. A branching is a scenario you would see is basically when you're trying to filter out the data after you've done some common processing. So like an example that I gave is, let's say you have this large amount of COVID data, because all of us are talking about that right now, and you wanted to see how is it impacting, let's say, California, Arizona, and all the different 50 states. How would you do it? You would go and read that data. You want to be able to process it, maybe apply some data quality optimizations on top of it to say that, make sure that, the data is clean. That is your common pipeline. And after that, you want to possibly filter it per state. That's your basically branching. And what we are trying to do with this optimization is to make sure that you are able to execute the Spark application that you write for this use case in the most efficient manner. So run the common pipeline once and only once. Do not rescan any of the data that you've already read. And every subsequent pipeline is only, like, once you filter, you only read what is relevant to you. So that's the end goal here.
Great. Hopefully that answers your question. Awesome, Shivani. Well, great job with your presentation. And I think I see one more question, but I think we need to move on to our last but not least speaker. So I will pass it over to Franco. Just enough time.
Hey, everyone. Thanks, Karen. Go ahead and share my screen. Hey, everyone. My name is Franco Patano. I am a Senior Solutions Architect with Databricks, and I'm here to talk to you about some interesting functionality that I figured out recently, connecting up Excel to SQL Analytics endpoints. So I'm going to show you how that works and do a quick demo, and just explain a little bit about the SQL Analytics product that you might have heard of and how it fits into a data management stack. So if you've used Spark or Delta or Databricks recently, you've kind of heard of Lakehouse architecture, but essentially what it is doing all of your data management techniques from data engineering, data science, and data analytics all on one platform, which we call Lakehouse. What I'm going to be talking about today specifically is components around the SQL Analytics product. It is the BI and kind of data analyst environment inside of Databricks that helps analysts query the data inside of the data lake or the lakehouse using SQL and in an environment that they're more comfortable in. Just to go over a little bit about what you can expect when using Lakehouse. This is a benchmark that typically Spark has never been good at. It's TPC DS or Decision Science. This is a query processing and serving benchmark. So it analyzes the time it takes to query data out of a dim and fact or a Snowflake-like data model. And what we find is that when we test the price performance of this platform of Lakehouse against other cloud data warehouses, it either meets or exceeds the price performance. So what I really want you to take away from this is that you're not going to lose any price or performance by moving to a lake house type of architecture. We see most often than not, you're actually going to get a little bit better. But there are instances where it's not, so just keep that in mind. But essentially, you will get the same, if not better, price performance by this type of architecture. And when I talk about a SQL experience, what I mean is traditionally when you think of Databricks, like has been talked about today, it's a lot of, with all of the talks that have come before me, it's a lot of code inside of notebooks. Python code, R code, maybe Scala code. And traditionally, SQL analysts don't feel comfortable in a notebook issuing queries and getting them back. They much prefer a SQL box with a schema browser and an output window. And that's what this new SQL experience is. And it allows analysts to quickly find data that they need, query it, and then visualize it to help their business partners understand what's going on with the data on the data lake on Lakehouse. And specifically what I'm going to talk about today is the extensibility to all of the various tools that exist in the marketplace today to connect up with BI and analytics. Specifically, we have Tableau, Power BI, along with these other vendors out there like Looker and Click, where you can use these tools to connect up to a SQL Analytics endpoint to be able to do analytics live on your lakehouse so that you won't have to copy your data into another system to get good query performance, like a cloud data warehouse. And setting up these endpoints is pretty straightforward. You can create an endpoint. An endpoint is like a cluster, but it's more and it's simpler. You could have multi-cluster load balancing, which gives you high concurrency, which traditionally was not available with a Spark cluster, but it is now with endpoints. And then also you can enable low latency with a new feature we call Photon. Probably gonna have a different name. Eventually it's just an internal project name, but essentially that's gonna give you low latency. And traditionally you couldn't get something like that out of traditional Spark. And so that's what you're getting with these new endpoints is higher concurrency and lower latency on SQL queries. And so what we see organizations using SQL Analytics for is connecting up all your BI tools like Tableau, Power BI, or even Excel, like I'm going to show you now, up to these endpoints for your compute. And then having price performant efficient compute to do your BI analysis and even do exploratory data analysis on the data lake. So quite often than not, business users will come to a data analyst and they'll say, I cannot find what I need. I have this question that has been asked of me, either by leadership or a customer, and I can't answer it with our out-of-the-box reports, dashboards, or our data warehouse. We need to go back to the raw data and figure this out. And so this is exploratory data analysis. And we see that the business users and data analysts working together collaboratively to determine what data they have in their environment in order to take action on it. And then finally, you can build data enhanced applications where you can use the extensibility of the JDBC ODBC connector to extend into any application. And so with Databricks, you have Tableau and Power BI working better together. You can use the extensibility of the SQL endpoints to connect either of these applications up, and then you can use the SQL endpoint compute to process your queries to give you that really good price performance in the cloud. And what you enable here is one source of truth in your lakehouse to serve all your needs across your organization. So with that, let's get into seeing this in action. So this is the Databricks kind of homepage. Whenever a new user lands, they'll see this. In the lower left-hand corner, there's a new app switcher. This might be changing soon, but this is what it looks like now. And essentially, if you've been granted access to SQL Analytics, which is normally done via an administrator via the admin console, you will now have this app switcher and be able to navigate to SQL Analytics. Inside of SQL Analytics, my default homepage shows all of my recent queries on the left, so anything that I've recently used. On the middle, it shows my favorite dashboards, anything that I starred. And then I have my favorite queries, anything that I've starred. and I can quickly go back into a previously done query, and I can analyze it very fast. And so inside of SQL Analytics, I can do my own analysis, where I can pop open a query tab, I can write a select statement, and I can browse the metadata databases that exist within inside of the Metastore, just like a database or a data warehouse. And I can navigate the metadata and build SQL queries to my heart's content. And then I can even add visualizations. One of the great visualizations that I like that's built into the Redash tool inside of Databricks SQL is the pivot table. Quite often than not, a lot of organizations, a lot of business users really lean on pivot tables because it allows them to quickly slice and dice information very fast. And traditionally, this is why business users like Excel, because they can take a large amount of data, make a pivot table, and then they can answer all of their own questions, sort of like in a self-service way. And inside of the Redash tool in SQL Analytics, you can do the same. You can build a pivot table visualization, and you, as the data analyst, you can build the pivot table that then can be customized and presented to the business user, so that all in a web browser, you can send them a link, you can Slack them a link or Teams them a link. I don't know if that's the proper adjective for Teams, but okay, if someone has an idea, let me know. But what you can do is you can customize what parts of the pivot table you want them to edit. So if you want to take away the controls, you can. If you want to take away the totals, you can. Or if you want the business user to be able to slice and dice their own information, you can leave the pivot controls, and then you can send a link to the dashboard to the business user, and they can slice and dice it on their own. But when I talk to people about this in different conversations, they always ask, but yeah, I still want to connect to Excel. Can you do that? Let's try it. So in Excel, you're going to have to do some setup. And if you want the step-by-step instructions on how to do this, please reach out. I can definitely show you the doc. But essentially, the first thing you're going to have to do is create an ODBC data source for Databricks if you're on a Windows machine. I do have directions on a Mac, but let's get serious here. More prevalent, the prevalence of having Excel on a Windows machine is more prevalent than having Excel users doing this on a Mac. But we do have directions on how to do it on a Mac. Please reach out. So what I'm going to do is I've already created this here, but I'll show you what it looks like. You'll have to go to our website and download the drivers for the Databricks ODBC driver. I've already done that here, but again, if you want directions, reach out and we'll send it to you. We'll distribute them after the lightning talk here. And then what I'm going to do is I'm going to create a new ODBC source. I'm going to go to SQL Analytics, and I'm going to go to connection details for my endpoint. So here's my endpoints. Here's my connection details. I'll copy the server host name and paste that into server host name. I'll copy the port and paste that into port. And then I will use username and password, and I'm going to use token. Any user can generate a token by clicking on this button and generating a token. And then I will go into the advanced options, but HTTP options. I need the HTTP path, so I'll go over to HTTP path, paste that over here, and then I'll go into SSL options and enable SSL. I will note that if your organization has advanced security protocols where you need to attach certificates because you're connecting to an endpoint or a cluster that has certificates, this is where you would add those trusted certificates as well. I'm going to click test. Success, it works. All right, so now that I've set up the ODBC connector inside of my Windows machine, I will go into Excel now and connect to that data set. And what I do here is I say connect to ODBC, and since I've registered the DSN, I'm just going to choose Databricks. You can also use advanced options. If you have an existing SQL query, and so let's kind of round out the conversation. If let's say I am inside of SQL Analytics and I develop a SQL query, and I say I have a business user that says, yeah, I like this query, but can you give it to me in Excel? I can just go here, copy the query, go into Excel, paste it, and click OK. And what'll happen is now this data set will be available to the business user inside of Excel as a data source. And they can now, they can click transform data or load data. I really like transform. I really like what they've done with Power Query here. It's very similar to Power BI as well. So you can use either or. But one of the things I really like about Power Query's ability to do data profiling really quickly. So if you can see here, at the top in view, I've said, give me the column quality, column distribution, and column profile. And what I can see here is I can see at the top of every column, it gives me like this quick data profiling capability. And I can go through and look at all of my data and see what it looks like before I import it to Excel. And I can even do some data munging here and change data types if I need to, or do any steps. So from here, I would then import the data into my tab. And I'm going to close and load the data. And now the data is available for me in Excel. The same thing works with Power BI. If you have a lot of your tools in Microsoft tools and you want to use Power BI, you could do the same thing there. Here's a sample dashboard. But what I would do is go to the connections and create a new connection for this. And then I can copy and paste those same details from the endpoint screen to this area. So we see here that if we go to more sources in Power BI. With that, I think I'm out of time now, Karen, so I'll kind of stop there. But that is it from a high level. Any questions?
Thanks, Franco. That was awesome. I'm just checking YouTube. Looks pretty quiet. Okay, cool. We have a question on LinkedIn from Al-Shafiq. How will the cluster activated or started? Will it automatically start, or do we need to bootstrap before query?
Great question. So an incoming connection to an endpoint will turn it on if it's not on. So if the endpoint is not currently on, it will turn on with the incoming connection. On AWS, clusters usually take a couple minutes to boot. It'll usually just have to wait for that. On Azure, it's a little bit longer. You might hit a timeout while the cluster is booting, but traditionally, when the users are in there, cluster would normally be up already, or an endpoint would be up. But you can also schedule endpoints to come up during the business day if you need them to as well. And more to come on that. If you should definitely attend Summit. I don't know if Karen's talked about it yet, but she will tell you. You should definitely sign up for Summit, because if you're concerned about cluster boot up time, there might be some awesome announcements coming next week.
Yes, I did plug it at the beginning, and I've been dropping the link at different variety of sessions and to register for free as I can. So definitely have all that information. So I hope you'll join us next week. Actually, we have, let's see, one last question, Franco, if you can answer it, from Janil. Does SQL Analytics have support for row-level security for data when user connects from Excel or Power BI?
Great question. Yes, it does. So SQL Analytics does have table access controls. I don't have enough time to review it today, but if I do go over it in detail in my talk at Summit. So definitely check out my talk at Summit if you want to know more about data governance in general or doing table access controls. But yes, it does work from any of those BI applications, including Excel. Another question gets asked by an anonymous attendee in the Q&A. What would the performance be for larger data sets when we import to Excel? So two things. Another announcement is coming at Summit about transporting large amounts of data over the cloud. But in general, large data sets to Excel you're going to have the 1,000,000 row limit in a sheet, right? But Power Query gives you more than that. So as long as it fits in Power Query and your result doesn't fill more than 1,000,000 rows in a sheet, it'll still process. It is Spark, as you know, behind the scenes boosting performance. So big data is definitely supported. You know, there are some, when you have certain volumes, there are some issues transporting it over the cloud networks, but we have an amazing announcement coming at Summit regarding Cloud Fetch, what dramatically increases the throughput of transporting data over the cloud, specifically for like extracts in Power BI and Tableau, and then also when you're transporting data to Excel.
All right. So I think with that, we'll close it out. I think moral of the story is hopefully you'll attend Summit next week for more information and lots of cool announcements next week. So I just wanted to close out by giving a quick thank you and shout out to all our speakers today. Thank you so much, Franco, Shivani, Alyssa, Liang. Y'all did an awesome job. And I'm super excited to have you for our first community lightning talk session. So with that, I'll close out and say thanks everyone for attending and supporting the session. And hopefully there'll be more to come. So hope you all have a great rest of your day. Take care. Hopefully see you at Summit next week too.
Thank you.
Bye.
See you at Summit.
Bye-bye.
Thank you. Bye.